So this is my solution. Um, as you can see, there's virtually no crystals to speak of. I can't even see like the beginnings of crystals. Um, so while that may sound bad, I think it's probably okay because the timestamp on this is 4:40 on Tuesday. It's currently Thursday at 7:20. So I don't think that I would expect any crystals to have formed yet. I think this is probably should be a more long-term reaction. So basically, to sum up, we have no crystals, but I think that's okay. We'll check back in next week, obviously. So the first few steps of the procedure that we did were essentially centered around this one reaction in which more or less aluminum solid reacts with hydroxide ions in solution to form aluminum hydroxide, which is also in solution. We used a basic solution of potassium hydroxide because that decreased the pH, meaning that there were more hydroxide ions in the solution available to react with the aluminum. The last thing that happened was once we put the aluminum in there, there's black stuff that sort of drained out, which were solid impurities within the aluminum. We filtered to remove them. So the main purpose of reaction 2 is to introduce the sulfate ion into the solution, which is required to form alum because it's part of the compound. So the form that we added in is in sulfuric acid. An unfortunate consequence of that, however, is that a precipitate of aluminum hydroxide forms at the bottom of the solution, but that's also easily fixed because as you add more acid and change the pH of the solution, that dissolves pretty quickly, and you end up with, that's reaction 3, is when it dissolves. So the final part in the creation of the alum was the fourth reaction, and this is basically just the process of slow cooling, and that's a process of crystallization, with the essential principle being that a lower temperature causes the solute to be less soluble within the solvent, and that therefore it precipitates out as a crystal. After we've precipitated it out, we vacuum filter the entire solution, and we're left with just the alum crystals. So after you've created your alum crystals, the problem is that they're too small. So we begin the process of recrystallization to make them bigger. The first step is just to remove any impurities, and this is done by washing it with an ethanol distilled water solution. We did this about 3 times, and how it's done is you basically just put your alum in the vacuum filter and soak it and filter it out, just repeatedly. And then the next part is we wanted to saturate a solution, and we did that by just taking a water solution and putting as much alum in there as we could until it stopped dissolving. Once it stopped dissolving, you vacuum filter out any excess alum that's solid left in there, and cover with a Kim wipe, and just sort of wait for the solution to evaporate. So the process of growing crystals of NaCl would be pretty similar to the process that we did after we had taken the alum out of the ice bath. Basically what you're going to do is you're going to take some NaCl and dissolve it in water and just keep putting more and more in until you can't dissolve anymore. And at that point, you essentially just wait for it to evaporate, and as the solvent evaporates, the solution or the solute will naturally precipitate out. So a separate method of forming crystals that I found is called the convection method. And to do this, you basically take a really long cylindrical shape and put your solution in there. And then you're going to angle it with the bottom of it in a heat source and the top away from the heat source. And what happens is the dissolved substance is inside there, and as it heats, it gets hot, so that rises because of convection principles. And then as it rises, it also cools down, thereby forming crystals through that heating, cooling process.